Okay, next is Jim Hamilton. He's a Wisconsin Distinguished Professor, Chemistry and Engineering Physics, UW-Platteville, Director, Nanotechnology Center for Collaborative R&D, and founder of Xolve, right? LLC. So development of graphene and its industrial applications, faculty entrepreneurship. Great.
Hello, and thank you all for coming. I want to tell you a little bit about some of the work that we've developed at UW-Platteville and then spun out into companies. And, you know, as we gather together today in this cathedral of entrepreneurship, I thought it rather appropriate that in the back of your minds, with every sentence I say about the things that have happened in Platteville, you repeat that this was done because of MJON and the WISES team. And if you just repeat that every time I say a sentence, then you'll understand the impact that WISES has really had on us here. So the Nano Center at Platteville is a collaborative center that works around the state with different organizations and individual faculty, ranging from Madison to River Falls and Point and Oshkosh. And so it started out to get the students out of Walmart and KFC so that they could work on doing meaningful research that was tied to their major. And so, so we have, it's really worked out with nice collaborative research. And so what has happened is that we focus on entrepreneurship and teaching students how to start companies and how it's possible, and also to bring in money to do both basic and applied research and work with companies in the region and indeed around the world on new technologies. So we have in Platteville spun out two companies so far. One is Photonic Cleaning Technologies, which is a polymer company that makes coatings for protecting and cleaning telescopes and aerospace surfaces and satellites, that has sales in 61 countries and distributors in 16, and works with all the big organizations around the world, like NASA and Lockheed and something. And actually in Platteville, we actually enabled the US ballistic missile defense system, believe it or not, with our polymer for protecting and cleaning optics. And with Xolve, we made fundamental new discoveries in nanotechnology that we were able to successfully raise a $2 million Series A in December and are making great progress. And we have 8 employees out in Middleton, not 3, you gotta fix your slide. And so, you know, and that's going really well, and it's very exciting technology that I want to tell you a little bit about. So on the upper left corner, you see a cross-section on a transmission electron microscope image of carbon nanotubes. And carbon nanotubes and graphene, that single sheet of carbon that the guys got the Nobel Prize for a year ago in October, this stuff is 1,000 times the conductivity of copper and 100 times stronger than steel. Electrons travel 100 times faster than they do in silicon in these carbon materials. And the problem with all nanomaterials, it turns out, is that they clump and bundle. And you see that cross-section up top. That's like if you go into the forest, cut the trees down, fly over in a helicopter, you're looking down at the tree stumps. So those are nanotubes. Those are magical super property things, but not when they're clumped and bundled as they are there. And what we discovered at UW-Platteville is a fundamental new principle in materials science, that the quintessentially insoluble materials on the planet that like to clump and bundle, like carbon nanotubes, like graphene, like titanium dioxide, other materials that are used a lot, can actually be exfoliated. And so when you spread them out, then they can actually have the super properties that everybody talks about and reveal the promise of nanomaterials. And so our company Xolve is working on developing technologies that really for the first time take advantage of this. People have promised for 15 years all over the world to take advantage of the magical properties of nanomaterials, and companies have burned billions of dollars in venture capital and really don't have many products except some better tennis balls or something. And so we're making a big impact on that. So what did we do? Well, through MJON and others and through WEN, we were able to enter and win the Governor's Business Plan competition in 2008. A very exciting process, very good for helping us learn how to start a company and progressively build everything. And so that was really great. And you know what then? The economy crashed. That was kind of annoying. But we kept going, and in that same year, we were one of the 30 hot startups in the United States in Business Week. And last year, we were one of the national finalists out at the Clean Tech Open in California, and so we've done pretty well. And indeed, we were also featured in even Scientific American magazine, which is pretty good for a school like Platteville. And so we've done pretty well. And we work with all these big organizations around the world, collaborations everywhere from China and Germany, Norway, Ireland, and all of that leads to companies and jobs in Wisconsin, and all of it is due to WISIS. And finally, we're also a very small part, and very happy to be part, of the Bionates tissue scaffolding theme here in this building with Tom Turing and others. And so Tim Leyden at River Falls and we at Platteville are making nanomaterial polymer scaffoldings, and we're just at the beginning of that, but that's for personalized medicine, so that if you, say, have an ear get knocked off on the farm and it's all jumped up, they can take cells, 3D print. Some of you saw the 3D printer downstairs. Print this ear, put stem cells on it. The cellular scaffolding will make the cells differentiate along with some chemistry, grow a new ear or grow a new kidney that's your own. And so we are able to play some small part in that. And this kind of teamwork is really exciting for all of our students and all of us. And I hope that we can continue. And thank you very much.